Welcome to this video tutorial on linear equation word problems. We're going to look at two problems similar to ones we discussed in class. Try them out, maybe press pause, and then see if you got them correct. First thing we do is we have this table, and we title each of the columns the following: object, rate, time, and distance. And the key to this table is the concept that rate times time is equal to distance. Now in this problem we also want to fill in what the two objects would be. On the one hand, we have a trip upstream from an origin to a destination, and on the other hand we have a trip downstream. So when we fill this in, we will use those labels: upstream and downstream. Now the rates. Let's think about this carefully. In calm water, the rate is 12 miles an hour. When going upstream, you're working against the current, which is 4 miles an hour. So we would subtract. 12 minus 4 is 8. It's also wise to put the label under the column, miles per hour. Downstream, the boat works with the current. So 12 plus 4 would be 16 miles per hour. Now we're going to express the time in hours so that when we factor label and cancel, our distance will be expressed in miles. But there's a problem. We don't know what the time going upstream is. So let's call it X hours. Now this entry is going to be the key to this problem. It takes a total of 5 hours to go both upstream and downstream. We use X hours upstream. How long would it take going downstream? Well, it would be 5 minus X. If X were 1 hour and we spent 1 hour going upstream and the whole trip was 5 hours, then it would have to be 4 hours that we went downstream. So once we figure that out, we just multiply across. 8 times x is 8x. 16 times the quantity 5 minus x gets us the distance over there. And to form an equation that we can use to solve this problem, we will have to use the distances. Now think carefully. Is there any difference in the distance making this trip upstream as opposed to making the trip downstream? No. We're traveling between the two set points. So those distances will be equal, and that's how we form the equation. Solving for x, don't forget to distribute the 16. So it'll be 80 minus 16x. Add the 16x to both sides. We get 24x is equal to 80. And we can divide that out. 24 divided by 80 divided by 24, we have to divide both sides by 24, is going to get us 3.3333333. Most of the time in word problems, decimals are fine. If I have another preference, it will be stated in the problem. You could use your math fraction command to see that x is 10/3. But don't stop there. We need to answer the question. And the question asked us, how far away is the destination from the origin? X is the time, not the distance. We could really plug into either of these two expressions, and they should be the same, because the distance upstream between the origin and the destination should be equal to the distance downstream between those 2 points. So we're going to take 8 times 3 1/3, or you could keep all those decimals, 8 times 3.3333333, and it comes out to be 26.67. Don't forget your label on the 26.67. It would be miles. And if I had asked for a fraction, don't forget that you've got the fraction button on your calculator that you could always use. Let's go to the second problem. A work problem. Now, we approach the table the same initially, where we say object, rate, time, and distance. But we are going to change it up just a little bit. Because really, instead of an object in this case, we're talking about people. So we could title it as person. And we're really not talking about distance, we're more talking about the work. Now, I wouldn't take off if you left those titles the same as we always title it, but technically that's what we would look at. Here the people are Josh and Jim. And the rate column is going to be very important for us in this problem. We're going to express the rate as the number of jobs they complete per minute. So in this problem, Josh completes a job in 85 minutes. One job in 85 minutes. It's a fraction. Whereas Jim completes one job in 60 minutes. Again, a fraction. The key to this problem is to realize that the time is the same because they're working together. So if it were to take Josh X minutes, it would also take Jim X minutes working together. When we factor, label, and multiply, the minutes cancel, and we're left with the number of jobs. So multiply across. It's based on the idea that rate times time equals distance. This would be x over 85, and this would be x over 60. The key to this problem is to realize that combined, they are going to complete one job. So x over 85 plus x over 60 equals the one job they work together. Probably the easiest way to solve this equation is to factor out the x. We're left with 1/85th plus 1/60th is equal to 1. Use your calculator and please keep it as fractions until the very end. I know I've said that decimals are okay, but you have to wait until the end, otherwise your answer is going to be a little bit off. So 29 over 1020. Use the math convert to fraction on your calculator. And if we want to solve for x, we need to multiply both sides by the reciprocal of 1020 over 29, 1020 over 29, because they cancel on the left-hand side. And we would get x is equal to 1020 over 29. Decimals, please, because we want to actually be able to interpret this answer. When we divide, we get 35.17. Please put a label on it. That's the time in minutes, so our answer would be 35.17 minutes for the final answer. Oops, let's highlight that in a different color. Make it clear what your final answer is. And last but not least, does your answer make sense? So if it took them 85 minutes and 60 minutes individually, they should be faster working together. And this is actually a little bit worse than half of Jim's pace. So it makes sense in this problem because Josh wasn't as fast as Jim. So it almost cuts Jim's time in half, but not quite. It makes sense, follow this structure, and you should be able to work these problems out successfully.